Okay, welcome to Shabit Uganda e-learning. My name is Nelson, and in today's lesson we shall be looking at finding how to represent prime factors on a Venn diagram. Okay, in this lesson we shall be able to look at how do we present these prime factors. That simply means we shall be able to first get these prime factors, or the prime factorization, the lowest common multiple, and the greatest common multiple. How do we represent them on the what? On the Venn diagram. Then also, how do we answer the related question that might be asked when dealing with the Venn diagram. Okay, so using our concept of sets that we did in our recent videos, we shall be able to understand and answer questions that are concerned with this. So so far we had looked more about prime factorization, and also getting the LCM, also getting the lowest common factors or the greatest common factors by prime factorization. That was in our recent videos, and we are able to calculate and see how do we really get them. Okay, so in this video we want to go direct by representing these these prime factors on what? On a Venn diagram. They are given as they always say, find the prime factors of 12 and 18. So here what they always say is to say that represent the prime factors of 12 and 18 on a Venn diagram. That's how they do set such question. Represent the prime factors of 12 and 18 on a what? On a Venn diagram. That simply means we have to first find the prime factors of these numbers of ours, 12 and 18. We have to first find the what? The prime factors of these numbers of ours. We can use either methods or ladder method or the factor tree method. So here we are able to use the factor tree method. We said when you use the factor tree method, that's when we are going to separate our 12 and 18. So here we had our 12, and then we look out for the number that can be the lowest number that can divide the 12, and we get no remainder. We have a 2. Okay, so we say 12 divided by 2, we get 6. Then we also look for the lowest number that can divide the 6 without a remainder, 2. Then 6 divided by 2, we get a 3. Then we also look out for the number that can really, okay, let me sort out this. Alright, let me sort out this. Okay, we are able to look at what we call prime representing these prime factors on a Venn diagram. We said for us to be able to work up on these numbers, we separate this 12, then 18. Then we look out for the number that can be divided by 12, and we get no remainder. Okay, so it is a 2 here. So we say 12 divided by 2, we get 6. Then 6 divided by 2, we get what? We get a 3. Then we also look for the number that can divide 3. It is a 3 divided by 3, we get what? We get 1. Okay, so when we get now all those figures, now this simply means that our 2 here, we have our first 2 here and our second 2 here, then our first 3. So this simply means that 2 is used 2 times, happens 2 times to divide these numbers of ours. Okay, so also here we have what we call our 18 here. We also look for the lowest number that can divide 18, and we get no remainder, which is a 2. We say 18 divided by 2, we get 9. Then also we look for the lowest number which can divide the 9, which is a 3. We say 9 divided by 3, we get 3. Then also we look for another one which can divide a 3, which is a 3. Then 3 divided by 3, we get 1. So this simply means that our 2 happens here 1 time, our 3 also 1 time, and still our 3 2 times. Okay, so now this simply means that we have our 2 here and our 2 here. Okay, 2 times, 2 happens here 2 times, and also 2 happens here 1 time, but 3 happens here 2 times also here 1 time. Okay, So now we shall be able now to look at now representing how do we put these in on the Venn diagram. Okay, so let's look at how we put them on the Venn diagram. So remember, our Venn diagram is having two factors. The factors of what? Factors of the prime factors of 12 and the prime factors of 18. Now, for us to be able to represent this on our Venn diagram, what we have to first identify using our basic concept of sets, we said that when we have numbers that appears 2 times, okay, it appears in 12 and it also appears in 18. So we have to identify them. Which one are they? We have a 2 appears here, one time. We have a 2 appear. Does it appear 2 times here? The answer is no. So we shall first leave out that one. We have also a 3. 1 also appears. 3 appears one times here. Also appears 1 time here. Okay, we have this 3 appears here 1 times. Okay, so we have our 2 1 and our 2 1 here appearing in both what? In both it is both a prime factor of 12 and a prime factor of 18. So we have the only those that are remaining. We have a 2 here, only appear in 12. We also have 3 2 only appear in 18. So this simply means that we shall first now identify these that appears on both, then we put them together. Okay, so when we put them together on the Venn diagram, remember we are having two prime factors, prime factor of 12, then the prime factor of 18. So we shall have our 2 here, 2 1 and 2 and 3 1, because they appear both in what? In in 18 and 12. So now what is remaining according to our prime factors here? We have a 2 which was remaining, and we have a 3 2 which was remaining. So that's why we are now putting our 2 here. It only belongs to that one, does not appear this side, and also our 3 2 only belongs in 18, doesn't appear in that one. So we have now presented this on a Venn diagram. Okay, so now what are these related questions that they always ask? Okay, so the related questions that are always asked are in the form of this. We have part A here. Okay, our part A, they are saying find the greatest common factor of 12 and 18. The greatest common factor of 12 and 18. From our method that we have been using, finding the greatest common factor of 12 and 18 using prime factorization. Okay, so now here, how do we get this prime, the greatest common factor of these prime factors? Remember, we want to get those prime factors that are common. Okay, that are common. So simply here we had our what? We had our 2 here. Okay, our 2 1 here, and we also had our 2 1 here. We had our 2 here and also had our 2 here. The greatest common what? Common factor using prime factorization. Okay, so now for us to be able to get this, those that are common, we have our 12 of F1, then intersection what? Intersection F. So in this intersection we have this. Okay, this is common, and also this is common. Likewise here, when you look here, we have our common here. We have a 3 1 which is common. A 3 is dividing a 3 here and also a 3 here. Okay, so we have our common numbers. We have a 3 here and we also have a 3 here. Okay, we have it here and we also have it here. So now this simply means that for us to be able to find the greatest common factor of 12 and 18, we shall be able now to look at our 2 here and our 3 here. So we just multiply them. When we multiply them, then we shall be able to get our final answer. Then when they ask us to get the lowest common multiple by factorization, we said this is the same as the prime factors of 12 intersection the prime factors of what? Prime factors of 18. Okay, so they are saying intersection. Intersection, we said using the concept of our sets, we said intersection, I mean union, means you get all the members in both sets without repeating one. Okay, so we have our 2 here. Okay, 2 2. We have our 2 what? 2 1. We also have this. We also have this. So this simply means we shall have our 2 1, then 2 2, then 3 1. This. So when you multiply now our 2 times 3, then times this, we shall be able to get our answer as 36. So that is how we can now solve numbers that are on a Venn diagram, and how we can represent those numbers in a what? In a Venn diagram. We shall also be able now to look at different questions that are always asked concerning prime factors on what? On Venn diagram. So for this, I do say thank you very much for being part of this lesson. Please be able to check out on our playlist and be able to subscribe in order to get some more upcoming lessons. Stay blessed. Nice moment.